Hello, everyone. Thank you for joining. Here is we're starting the meeting and webinars about the green transition with our portfolio for close controls applications and the latest solutions that we are proposing. Microchannel is on board to give you the show.
Hi, everyone. Some practicalities maybe before starting.
Yeah, so a few practicalities. It's by default, you are muted. So you cannot speak, but you are very welcome to ask your questions in the chat box or in the question box. And we will reply either directly or at the end of the presentation. But it's a long presentation, so we might not have time to take all the questions today. Then be aware that this presentation is recorded and it will be made available after Mostra on the platform or directly on YouTube from Danfoss platform. And then that's it. Go and have a great show, Mathieu. Thank you.
Thank you, Laure. So thanks, first of all, thanks for joining this Danfoss session about our portfolio for close control application. Which is one of the application for data center. So some words about myself. So I'm Microchannel. I'm the marketing director for the former, let's say, Danfoss cooling portfolio. I started at Danfoss in 2016 as a marketing manager for compressors. My area of expertise or my main knowledge is about compressors and mainly variable speed and fixed speed scroll compressors. And then since 2 years, I've been expanded the portfolio to the remaining portfolio of Danfoss, heat exchanger, line component, electric expansion valve, and controllers. So I have between bracket some knowledge around the air conditioning system, such as chillers, rooftop, heat pump, and then close control application that we're gonna discuss during this session. So a few words about the data center market. We all know that the data center market is a market that is in high expansion. We are foreseeing a growth that will be from 2020 up to 2025. That will be around 12%, 12.5% according to Mordor Intelligence. So this growth is mainly fueled by the significant increase of the number of data centers that are being built due to the increase of the number of IoT devices and high computational requirements done by artificial intelligence and media applications. So of course, growing market is always nice, and this data center is growing quite a lot due to this, but there are some drawbacks in the growth, and the main drawbacks is that those type of application is a huge consumer of CO2, is a huge consumer of electricity, and the latest forecasts are foreseen that data center in the near future will account from 2 to 5%, depending on the sources, of course, of the greenhouse gas emission worldwide. Just as a parallel, for example, civilian and military aircraft, for example, they represent 4% of the total greenhouse gases emissions. So that will be in the same magnitude. And out of this consumption of CO2 emission, the cooling of those data centers, they will represent almost 50% of the consumption of those units. So here in this slide, you have a pie chart that is showing the distribution of the power consumption. So like I said just previously, the cooling system, they stand for, like I said, 45-50%, depending on the sources. But this is the main part of the consumption. And then you got the IT load and the power distribution and the lighting that are making the over 50% of the consumption. So within those 50% due to the cooling system, the cooling unit itself, they represent roughly from 50 up to 70% of the total consumption. And the remaining is mainly due to a distribution system such as a water pump, fans, and other heat exchanger equipment such as air cool fan, etc. So there is a the system unit, like I said, it represents almost 50 to 70% of this consumption, and we need to find ways to improve as much as possible the energy efficiency in order to reduce the global footprint of the CO2 of this type of application. So, of course, one way to improve the energy efficiency will be to focus on the component, and the main contributor of that at the system level will be the compressor, to improve the efficiency of the compressor. So at Danfoss today we have different type of compression technology coming from the scroll for a unit that will go from 50 to 200 kilowatt for close control application, and from a chiller going from 150 kilowatt up to the megawatt with a multi-scroll solution for air-cooled chiller, for example. So here we are able to offer either variable speed solution for close control application and fixed speed compressors that can be manifolded for air-cooled chiller. So that will be maybe targeting the low-end capacity market, and the high-end capacity market. We have our, you are all aware of this, our turbo-core technology. That is our premium product, giving a tremendous and high efficient performance for water-cooled and air-cooled chiller. So if we are focusing only that, we are already well equipped, and we are still focusing and developing new solutions in order to enhance even more the energy efficiency of all of our compression technology. But if we also look at the system level, one thing that may also improve the energy efficiency of the system is to increase as much as we can the chilled water temperature in case of a chiller. The higher we go, the higher the water temperature is, the better and the more favorable the condition is for the compressor, and then the energy efficiency is then on the application level better. And it's the same, so chilled water temperature for chiller, and could be also the supply air temperature for an applications such as close control. So requiring more and more higher evaporating temperature in order to minimize as much as possible the impact of the performance. And one other thing that also may improve the energy efficiency is to use as much as possible free cooling instead of having mechanical cooling. So the location of the data center is also important. The northern you go, the less you have to run the mechanical cooling to cool down your data centers. So those are things that we need to think of, and at Danfoss component level, we need to focus more on optimizing as much as we can our portfolio. So there are different type of data centers, and different type of data centers will imply a different type of application. Okay, so most of the time, the main data centers that we all know are what we call the enterprise data centers. So those are facilities that are built and used exclusively by one single company. So the size of the data center can go from hundreds of kilowatts up to some megawatts, and in case this company becomes a giant such as Amazon, Google, then it is what we call hyperscale data center. Okay, and then the capacity can go from several megawatts up to 100 megawatts. According to the capacity, then you have a different type of technology and system that may be used. So for data center that are relatively small, such as telecom data center, then the use of close control application will be more, let's say, spread, because the capacities are more fitted for this type of technology. And when you go to the hyperscale or co-location data center, then the need of cooling is getting higher and higher. So you will have the use more of indirect systems such as air-cooled chiller or water-cooled chiller in order to meet the demand, the cooling demand. So what does it mean in terms of architecture? So this is what I just mentioned briefly. So we have different type of architecture. Of course, we have one thing that is commonly spread is the free cooling, and at Danfoss we have already a wide range of heat exchanger portfolio customized for this free cooling under the brand of Sondex. On top of this, we also have a wide range of portfolio for chiller application, whatever air-cooled or water-cooled chiller application. So for air-cooled chiller application, either we have a scroll solution that can go from 50 kilowatt up to the megawatt with a multi-scroll possibility using Quadro, for example, 2 circuits to Quadro. Our solution on scrolls are already qualified with low GWP refrigerants such as Fortinet, 4B32. And if you attended yesterday the presentation of Mathieu Stoll, we are also coming with solution with 1234ZE in this type of segment. And on the high-end capacity from 500 kilowatt up to several megawatts, we have our well-known, like I said, turbocore technology that are now specially and specifically designed to operate at high evaporating temperature for this particular segment. So this is what we have for chillers, and this is where I'm going to stop the promotion of our chiller solution and focus more now on what we have for close control application and the dedicated portfolio that we have. So today, for the close control unit, so the close control unit are units that are located within the server room. Okay, so it's a refrigeration system within the server room, close to the server room. So it's an air-to-air system, mainly using high density refrigerant, and the latest design are using R-Fortinet. So for this type of architecture that we are talking about, ranges that goes from 20 kilowatt up to 150, 200 kilowatt capacity. We have ranges of scroll compressors and mainly inverters compressors. The name is the VZH compressors that I'm just going to talk briefly right after. On top of this, for the remote condenser, we have a solution with a microchannel heat exchanger in order to reduce the charge of the refrigerant and also to increase a bit the energy efficiency versus traditional fin and tube. We are also coming with new set of electronic expansion valve with the latest release of the ETS 5M that is completing our range of the ETS Colibri. We also have a bunch of line components such as check valve, filter dryers, etc., pressure switches, and that are needed also for this type of application. And lately, we revamped our electronic control with the launch of 2 new models of electronic controller, the MCX 15 and 20B2. What is new in this portfolio for this type of application? So last year we worked to come with a subsystem solution around our variable speed technology. So we pre-qualified some package in order to get the best of the variable speed compressors in terms of performance and in terms of reliability, in order to shorten the qualification time and accelerate also the development time for our OEM. So what is it, this subsystem solution about? So we pre-qualified and predefined some downforce components, such as, of course, the variable speed compressors and its drive, the CDS, with some dedicated, according to the size of the compressors, we have dedicated valves that are qualified, so the ETS Colibri and the ETS 5M, a set, of course, of temperature sensors, DKS, and low pressure and high pressure transducer, the new DSTP 110. And everything is managed by what we call a reliable controller, the MCX 61, that is an intermediate piece of hardware between the main controller of the unit that is handling directly the oil management of the solution of the VZH compressors, that has already predefined the envelope of our VZH compressors inside, and that is already and it is also monitoring the electronic expansion valve. So this reliable compressor is in fact already preset to take care about oil management, map control, and superheat control. And this can be connected directly to the main controller, so that to easy the integration of this solution, of the variable speed solution for the OEM. So the OEM does not have to bother anymore about the envelope control and also the superheat and the oil management. That will save him time and give him a reliable solution. So this is what we are coming with as a pre-qualified package. But on top of this, we also had improved a different component, and this is what I'm going to show you right now. So focusing first on the compressor. So like I said, we have this variable speed range called the VZH, coming from the lowest variable speed compressors, the VZH 28, that is giving at the EN 12900, so 5 degrees evaporating, 50 degrees condensing, 10 degrees superheat, and 0 degrees subcooling, roughly at 90 RPS, 12.9 kilowatt cooling capacity as a standalone compressors, up to the VZH 170 that as a standalone compressors gives roughly 83 kilowatt. Okay, so this is what the compressors are able to give as a standalone, and we have offered since many years now possibility to manifold the large variable speed compressors with fixed speed compressor. Up, for example, to the VZH 170 with the DSH 295, and as a combination of hybrid tandem, we can go up to 150 kilowatt on a single circuit. So we patented and worked since many years, more than 7-8 years now, this type of solution. And contrary to the competition, we have quite a robust and mature solution when we are talking about hybrid manifolding and oil management. So what are the key features for close control application there? So those compressors, they are all able to evolve at higher evaporating temperature. The bigger one, the 88, 117, and 170, they are able to evolve up to 25 degrees evaporating temperature, while the 65 down to the 28, they are able to evolve up to 27 degrees evaporating temperature. And this is something that is needed for a CRAC application where the supplier demand is getting higher and higher. I will not talk a lot about our IDV, because this is something that we launched more than 5 years ago, and I don't think that we need to enhance something. But just to say that our variable speed compressors are all equipped with IDV that enhance the part load, the performance at part load condition. All of our compressors, they are equipped with pre-qualified package compressors and drives, and they're going to be available with A2L refrigerant from Q3 2021 and onwards. So just to highlight some stuff about the performance of the compressor. So lately we run some simulation on the 50 kilowatt system on the CRAC system, using the compressor that was used was a VZH 65, and we were comparing the performance against the competition. So we defined a load IT load profile that is combining its weight between the IT load and the impact of the weather. All in all, what to say there is that the lower we go in part load with our variable speed compressors, the best we can get in terms of performance versus the competition. And here, for example, at this condition, that was around 30 degrees condensing temperature and 15 degrees evaporating, our compressors is giving 7 to 8% higher COP than the one of the competition at the unit standpoint. So it's just to give you the benefit of the IDV there on a standard CRAC unit architecture. So that's it for what was new on the VZH platform, soon to be qualified with A2L refrigerant within this year. What is also new is that on the electronic controller level, we are coming with a new MCX, so it's a little bit different. So this is not the reliable controller that I've just showed previously 3 slides ago. So this is the MCX 1520 B2. So those are the controller for the main unit. Mainly main benefit of this new revamp of the controller is that we increase the number of I/O on the versus the previous generation of the MCX. We also changed the internal processor to get higher execution speed and increase the memory capability. And we also added the web connectivity to this new set of controller, and increasing also the security. That's going to be exactly the same protocol of security than in banking, for example. The controller is also of course available with and without display. So this is something that came on top of the reliable controller that I showed you just before, in case it's needed. So this is something new that we released last year in 2020. For what concerns the electronic expansion valve, today we have a portfolio that we are currently investing in it. Sorry, difficult to say. Today, for what concerns the close control application, you can see on the x-axis in red, sorry, the capacity of the valve with our Fortinet refrigerant as those rating condition. And in black, this is the one with 134A. So we decided to show our Fortinet because for a close control application, we are not using at all low density refrigerant, so there is no point to highlight this. What we can say is that for close control units from 20 kilowatt up to 200 kilowatt, the range of the ETS will go from the smallest ETS 5M that we just released last year up to the ETS 50C maximum. So that will be the range of Colibri and ETS that's going to be used. So this one, the ETS 5M is our latest baby that we just released, and I'm going to have a small highlight on that. Just a quick comment that is not linked to close control application, but it can be that can be highlighted for chiller application, is that we're going to release the additional sizes of large expansion valve, large ETS. So the ETS 175 L, the ETS 550L, that will be able to reach almost several megawatts, this one. And we are able also we're going to release the some manifolding version. So that will fit the air-cooled and water-cooled chiller demand for data center application. So not really for close control, but this is something that just wanted to highlight there. So the new ETS 5M, so like I said, the ETS Colibri had been released 5 years ago, so I will not spend lots of time there. Just want to highlight and give some comment about the ETS 5M. So this is our smallest electronic expansion valve that we released, like I said, last year, and it's going to fit a close control unit up to 25 kilowatt cooling. So really the low end of the CRAC unit, maybe the first two models that will fit with this valve. So this valve has been designed to be as compact as possible to operate really smoothly and really quietly. So it's a biflow valve that is working with full performance in both flow direction. One takeaway is that the MOPD of this valve is 35 bar, and it is already qualified with all the future-proof refrigerants, such as, of course, our Fortinet for this type of application, but we are also foreseen 32, 454B in the near future. You also have to know that this valve is qualified not for close control application, but for other type of applications, such as residential heat pump, for example, for R290 and R454C. Those valves, this particular valve is already compatible with all of our existing valve drivers, and not our preferred solution, but it can also work with the valve driver of the competition. So this is the newest addition to our portfolio, and that may be interesting for the close control application. And to finish, regarding our portfolio of components, let's talk a bit about our microchannel heat exchanger. So nothing really new there for the close control application, but just to highlight that we have in the Danfoss portfolio a microchannel heat exchanger option that may be customized according to the need of the OEM in order to improve the overall efficiency of the system and reduce as much as possible the refrigerant charge. Of course, you have different sizes of manifold, tubes, tube and fins. I will not spend that many times there. Our microchannel are optimized with R14A, so nothing really new around the R14A side and our microchannel portfolio. But just a quick comment out of the close control application is that we just released a new microchannel optimized for low density refrigerant that will be much more beneficial for air-cooled chiller using 1234ZE. This new optimized design will lower the pressure drop on the refrigerant side and will help to increase the performance of the unit versus a traditional optimized microchannel for using 134A. So this new microchannel has just been released in April this year, and the new name is the C725 optimized for low density refrigerant and 1234ZE. Not really the purpose there for R14A, nothing really new, but just have to know that in case you want to use microchannel for a remote condenser in your close control application, you may contact your local Danfoss sales partner, and they will help you to make the selection for this type of solution. Like I said, our microchannel, we have microchannel optimized for the R14A design. Then we also have those microchannels that are qualified with 454B and 452B, and also qualified with R42. Be careful for R42. The pressure needs to fit the 49 bar needed for to be qualified. So it's just a reminder, this is not the same than with R454B, R452B, and R14A. So that makes quite a good transition, and the fact that our microchannel are qualified with alternative refrigerant. And let's talk about the phase down. So the close control application, like I said, they are using mainly today R14A. We are in Europe, and today in 2021 we had a big crunch of the quota of the F-gas, the minus 55%. It seems to be that for the next 3 years we will not face any availability. With R14A. The prices are remaining quite okay right now. So R14A will continue to live in the next 3 years, 2 to 3 years in Europe. But in 2024 there will be a next crunch of the quota of the F-gas, and we know that for sure from 2024, 2027 there will be a higher pressure in Europe regarding the availability and the price of R14A that will imply maybe the change of refrigerant. The same logic will happen with delays in other parts of the world, in North America, in Asia, etc. But as of today in Europe, this is where the pressure will be in the near future. Of course, as of today, like I said, close control units, they are using mainly R14A refrigerant as the next in line refrigerant to replace R14A in high density fitting variable speed scroll, for example. This is R32 or R454B. The main drawback of those refrigerants is that they are flammable, and that could be quite a question mark for this type of application. And those refrigerants, we could not consider them as endgame refrigerant because the GWP is good. It's below 750, which is 1/3 of what was R14A, and if you consider 454B, it's even 1/4. But still, we may have concern about the really long term of the solution. So as of today, below 150 replacement of our Fortinet, nothing is really available. And most of all, if we need something that is non-flammable, then we will have to switch to what we call low density refrigerant to find something that is non-flammable and with a GWP that may be of interest for this type of application. Candidate maybe R513A, but the GWP is still a bit high, 650, around like this. Or one that may be interested is the R515B. It's composed of 90% of ZE, and the GWP is below 300, and it's non-flammable refrigerant. Could be a good candidate, but going to this type of refrigerant will have a tremendous impact on the applied cost of the unit. The heat exchanger will be bigger, piping will be bigger, and we all know that cost is always sake of importance. So we may have question for the future of those type of application when we will switch from our Fortinet towards alternative refrigerant. First thing that I've already highlighted is this application is really sensitive to flammability. This is direct expansion system that is close to the server room. And you can imagine that the acceptance of the data center owner will be quite limited to get a flammable refrigerant close to its server. They don't want to have their server to go to flame for sure. So this is something that will be for sure a concern and can be a roadblock for the adoption of A2L within this type of application. So if we are considering A1, that would be, I guess, the preferred solution of those for those type of application. Today, there is no, like I said, no alternative of high density refrigerant with A1. So in case we have A1, but they are low density, and that will have a tremendous impact on the cost. And if the A2L is not accepted, we may have an impact on the future of this technology, of this close control technology, and there may be a switch toward more indirect system, such as air-cooled chiller or water-cooled chiller, where the flammability topic will be put outside of the building. So in any case, Danfoss will have whatever solution in case those applications are switching to indirect system. We will have compressors that will be qualified, compressors, heat exchanger, line components that are already qualified with the next A2L refrigerant in line, 32 R454B, and also the future endgame solution for the scroll technology above 200 kilowatt with 1234 ZE, and with turbo core for chillers we already have solution with 1234 ZE. And in case we need to find A1 solution, this is something that we will have a deep look in the future, but I guess we'll be ready soon. So that this slide ends up this presentation about our Danfoss portfolio for the close control application. You can find all the related information that I talked about within in Cool Selector, where you can find all the compressors, line component selection there. Of course, you can use our ref tool to get all the information for what concerns the refrigerant. And if you want to place an order, go to store.danfoss.com. It was a pleasure talking to you today. And if you have any question, then I think it's time to proceed. Laure?
Yes, thank you very much, Mathieu. Well done. I mean, you did the conclusion, and it's already time is over. So what I will invite you is to contact us directly on Danfoss booth if there is any more questions, and we captured everything here. So thank you so much, and have a great afternoon.
Yeah, thank you. Have a good day.